Alright, in this proof, we know that PQ is perpendicular to QS, TS is perpendicular to QS, and R is the midpoint of QS. So that is our given. Okay, let's start with PQ is perpendicular to QS. If PQ is perpendicular to QS, then angle PQS, also known as angle 3, is a right angle. Angle 3 is a right angle. And that is the definition of perpendicular lines. I also know that TS is perpendicular to QS, so I can say that angle QST, also known as angle 4, is a right angle. So I'm going to go ahead and just put those in the same step because they have the same justification. So angle 3 is a right angle and angle 4 is a right angle. Okay, then it tells me that R is the midpoint of QS. So if R is the midpoint of QS, then I can say that QR is congruent to RS. By the definition of a midpoint. And then I notice that we have some vertical angles, so angle 1 and angle 2 are congruent by the vertical angle theorem. Okay, so you might be thinking, Ms. Briscoe, we're good to go. We are ready to say that these two triangles are congruent by angle, side, angle. But hold up a second. I have to be able to find 3 congruent statements in my proof before I can use angle, side, angle. I have to prove one pair of angles are congruent, one pair of sides are congruent, and then another pair of angles are congruent. So right here, here's my first pair of angles, check. Here's my first pair of sides, check. But I don't have another statement in my proof right now that says my second pair of angles are congruent. I know that angle 3 and angle 4 are both right angles, so I need to say specifically in my proof, that those two angles are congruent to each other. So I can say angle 3 is congruent to angle 4. By the right angles congruence theorem. Because both of those angles are right angles, I can go ahead and say that they're congruent. So now that we've proven that we have 2 pairs of angles and 1 pair of sides that are congruent, now we have enough information to say that these 2 triangles are congruent by angle, side, angle. So I can go ahead and put that in my proof. Triangle PQR is congruent to triangle TSR. By angle, side, angle. And so now that we've proven that the 2 triangles are congruent, now we can use CPCTC. So we want to think about what we're trying to prove. We are trying to prove that R is the midpoint of PT. Well, if R is the midpoint of PT, that would mean that we would need to prove that PR is congruent to RT. So let's look at our triangles. Oh my gosh, PR and TR, PR and RT, those are corresponding parts in these triangles. So I can go ahead and say that they're congruent. Segment PR is going to be congruent to segment RT or TR, doesn't matter, by CPCTC. Because those 2 triangles are congruent, their corresponding parts are also going to be congruent. And if PR is congruent to RT, that means that R is the midpoint of PT by the definition of a midpoint. So CPCTC, after we've proven two triangles are congruent, then we can use CPCTC, and sometimes CPCTC helps us prove something else in addition to just that the segments are congruent. So first you have to prove the triangles are congruent, then you can use CPCTC, and then you can do whatever else you need to do with that information.